Okay, good morning. Make sure you get your homework turned into the box. There were 10 questions in the bubble sheet. They should be stapled together. And then please do the valence electrons warm-up. You will need your periodic table to be able to do that warm-up. If you don't remember how to do it, as soon as I do attendance, I'll be walking around the room to remind you. Alexis? Okay. See if there's another one laying up here somewhere. Put it in the box. Anything you need to turn into the box. There you go. Level quickly. If you've lost your homework and don't have a bubble sheet, there's some extras up here. You have a few minutes to get that done. Right there. I think you turned yours in already, didn't you?
No,
Okay. Matthew, Annika, Dahlia.
You're not going to have paper on it?
It's right underneath it. Lane?
Sir.
I'm just doing attendance here. Would be fine. I just didn't see you. Raphael? Terry? Catalina? Okay, remember you have to use your periodic table to determine valence numbers on your warm-up. Remember, it's the A groups. Sorry? Yeah, put the homework in the box this time. I'm going to scan those. You'll get it back tomorrow and we will go over it tomorrow. Okay, so remember, valence electrons are these A numbers right here. So oxygen is right here, so we must have how many? There you go, that's all there is to it. Okay, remember how to do this? Okay, valence. Oxygen, right here. You go up and look there. 6. Magnesium, so there, it's 2. Okay, you keep going. Okay. Good. Yours. Let me see. No, you're wrong. Let's teach you how to do this. What is this? Where do you, I have your periodic table. I know I printed you one yesterday, now what I do? Okay, I'll have to print some more. You're there. Yeah, I'm here, we added some notes on this. So we have your pencil. These numbers right here represent the shells. Okay? These 1A, 2A,
3A, 4A, 5A, 6A, 7A, 8A represent valence. Okay. So oxygen, you go here, you go up and you see it's how many? It's that easy. Okay. I'm going to have to come recording this lesson, I'll send it out. That's right. Okay, you need your periodic table. Do that. If you have your journal with that, it should be in the back. Well, can I need you to do that, please? That's yours, please. Okay, I'm going to show you. And then into this note sheet like you were supposed to know every time, so I can have the information. Get yours up and follow along. These numbers here represent what? The shift. Okay. 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A represent valence. Do you find oxygen? And how many does it have? 6. You just couldn't see it, I went through over. Magnesium would have. That's how you do it. Okay, let's go over this. This should be relatively easy once you know the concept behind it. All you need is the periodic table in order to find the valence number, or the valence electron. So for oxygen, it would have been 6. That's the 6A group. So you go to the oxygen, you go up the periodic table until you get to the A letter, and it's the number in front of the A letter. You do not use the A. No. Do not put the A. It's just 6. Yes, ma'am. Okay, the next one, magnesium. Gracie, what is it? Was 2. Very good. Okay. And sodium is 1. So Chris, what was boron? It is 3. Francium, Sterling? It is 1. Xenon, Ren? It is 8. Very good. Big Chris, Germanium? 4. Everybody understand how to find that now? That is one of the questions that will be on the STAR test. It will be on your unit test Friday. You're going to be asked how many valence electrons does some atom have. Okay? You now know where to look for it. Okay, today we're going to move into something a little bit different. We're going to be still talking about atoms, but we're not going to be talking about the fact that atoms have equal protons and electrons anymore. Okay? We're moving on beyond that. Now, for 8th grade, for the most part, you need to always remember that the atom is neutral. What does that mean, to be neutral? That means it has no charge. Now, some of the particles in the atom have charge. What are the protons? Positive. And what are the electrons? Okay, but if you had 25 protons and 25 electrons, what happens to that charge? No. If you had 25 positive and 25 negative, 0. They cancel each other out. And that's the reason why the atom is considered to be neutral. They cancel each other out. Okay? Now, today we're going to be looking at something called an ion and an isotope. And you'll need to know the difference between those. Please, on page 17 in your table of contents, add isotopes and ions. Go ahead and fold this in half when you get it. Isotopes and ions. Yes, this is it. Now, when you're looking at an atom, like the drawings on the front of your foldable, I want everybody to look at them. The drawings on the top of your, on the front of your foldable. The top three little drawings of an atom are what are known as isotopes. And the bottom little atom is what is known as an ion. I want everybody to look at the isotopes on your foldable. It says hydrogen, deuterium, and tritium. Hydrogen, deuterium, and tritium. How many protons do those three have? One. They have one each. So, using your periodic table, in essence, if they only have one proton, what are all of those? If they just have one proton, look at your periodic table. If they just have one proton, what are all of those? Hydrogen, exactly. They are all forms of hydrogen. They only have one proton. So they are all forms of hydrogen. And again, we're looking at the front of your foldable. The front. Okay? What do you notice is different about those things? What's different about deuterium and tritium from true hydrogen? Look at the little models there. Right here. Right there. What is different about them?
Those two more neutrons in the...
Very good. So what's different about them?
They're more...
They have more neutrons. Everybody look at it. Hydrogen, how many neutrons does it have?
One.
Zero. It has one proton only. Deuterium, how many neutrons? One. Tritium, how many neutrons? So for isotopes, what can change? Neutrons. The neutrons can change. What I want you to do is take your highlighter and highlight that little word neutron right there. When you hear the word isotope, you should think neutron. Okay? Highlight that little word neutron right there. So when I say isotope, you say neutron, because the neutrons are going to change. Now, this is the reason why on the periodic table, which you should have open looking at, please. Okay, everybody open up your periodic table. This is the reason why on, somebody give me the mass of hydrogen on the periodic table. Read all of it.
1.008.
1.008. Freddie, where's your science journal? I'm going to move you to another table if you and Armando are just going to sit there and talk and you're not going to want to do any science. You're talking back to me and you were talking to me. Do you think I'm stupid? When your mouth, lips are moving and there's sound and air coming out of your mouth, that's called talking. Right? Okay, well then just keep your mouth closed and you have no reason to talk back to me. I'm not stupid. I can see and I can hear. Okay. So the reason why on the periodic table hydrogen has 1.008, that's the average mass of these isotopes. It's the average. So there are many different isotopes of hydrogen. Do you think there's hydrogen with just 2 neutrons? There could be 3 neutrons or 4 neutrons. Now most of it just has 0 neutrons. Okay? And that's the reason the average stays closer to 1. But the isotopes change. Okay, now look at the ion down at the bottom. This is sodium. Please look at sodium. The one on the left is called neutral. Sodium atom. Everybody write the word neutral right above it, and I will put it on the screen and show you where to write it. Okay, so this here is neutral. Sodium has 11 protons. That means it has 11 pluses. And it has 11 electrons, which are negative. Those cancel out. Can everybody see that there are 11? How many are in the first shell? 2. In the second shell?
6.
8. So that's 10, 11. So the 11 positives in the center get crossed out by the 11 electrons in the shell. But guess what? What did we say about these electrons? What do they want to have? They want to have a pair. They want to have a partner. If they don't have a partner, guess what they're going to go do? They're going to go find one. So that little valence electron is going to leave. And this is what you end up with. It's still sodium. But what does it have one less of? It has one less electron. So is it neutral now? Let's look at it. We still have 11 protons. So all sodium has 11 protons. But now, how many electrons do we have? We only have 10. So it's going to be a positive. The atom now is charged positive. It's no longer neutral. That's what's called being an ion. And many, many chemical substances form because of that. Okay? If you had a positive ion, what if it gained some electrons? Would it be positive then? Let's say it gained a whole bunch of electrons. It would become negative because there would be more electrons than protons. If you had a positive ion and a negative ion, like a magnet, what are those two things going to want to do? Stick together. And that's how other substances can be formed. So go ahead and open up your journal. Let's go through this. Follow along. You'll need to be drawing some stuff and filling in some blanks. And we're going to talk about this in a little bit more detail now. Okay. So, what is an isotope? An isotope is an atom with the same number of protons and electrons, but with a different number of neutrons. A different number of neutrons. It's the only thing that changes. It's a different number of neutrons. Now, isotopes can be written using symbols. The symbols for isotopes, there's two ways to do this, and this got off a little bit. Let me see if I can fix it real quick. Give me just a second, I'm sorry. Okay, there are two ways that you can show an isotope. Okay, scientists have two ways. You could either say sulfur 32. Guess what this 32 represents? It's not. Sulfur 32. One of those things we talked about. What's that? It's not the number of protons. It's the mass. Sulfur 32. Because remember, if the neutrons change, will the mass change? Yes. So this one happens to be sulfur 32. It could be sulfur 33 if there were more neutrons. Or sulfur 31 if there were less. And we'll look at that a little bit later. Another way to write it is here. Here, you just use the symbol. You put the number of protons at the bottom and the mass at the top. So you might see an isotope written either way. And there is a place on your paper to write those two down. Number 1 and number 2. What are the symbols for isotopes? Sulfur 32, or you can do it using that symbol there. Okay? Now, again, what change? If I say isotope, you say neutron. Okay, so the neutrons are what's changing. Okay, let's look at an example. The most common type of lithium has 3 protons and 3 neutrons. Okay? Sometimes, however, lithium will have 4 neutrons. Sometimes. It will have 4. So, here is lithium that has a mass of 6. It has 3 protons and 3 neutrons. Okay? And again, this diagram is there for you. You just have to fill in the numbers, which are in red. It has 3 protons and 3 neutrons for a total mass of what? 6. Occasionally, however, lithium will have 4 neutrons. And it will have a mass of 7. These are isotopes of one another. Okay? This one happens to be lithium 6. And then these are the two ways you could write it as symbols. Lithium 6, or you could put lithium, what does this number represent? No, this is the protons, and this is the mass. If you don't know that, label it in your notes. Okay? So lithium 6. There was one that it just meant, that just meant to go right here. Oh, yeah, no, you got those wrong. This is sulfur 32. Okay. So, again, lithium 6. And label those if you don't remember what they're going to be. What is that number right there? Protons. Label it. That is the mass. Label it. Okay? That's 6 and that's 3. What does the 6 represent? Yeah, it does. It represents mass. Label it if you can't remember that. What does this little 6 represent? Mass. Everybody label it. That's the mass. What does this little 3 represent?
Protons.
The protons. Label it if you can't remember that. Now the one on the other side is not lithium 6, it is lithium 7. And its symbol is like that.
7 mass, 3 protons.
Very good, that's exactly right. That's isotopes of one another. You don't know which elements on the periodic table have isotopes, you have to assume all of them do. The only way you would know what they were exactly from the periodic table is if somebody told you. Okay? So you can't find the isotopes on the periodic table. That's not something you ever have to do. You know they're there because every element on the periodic table has a mass that's a decimal. Okay? If the mass on the periodic table is a decimal, which is an average, you know it has some isotopes. But there's no way to know which ones. Okay? Let's take a look at another one. Lithium 6 and lithium 7 are isotopes of the element lithium because they have different numbers of neutrons. You can fill that in at the bottom down there. Lithium 6 and 7 are isotopes, and one of the blanks got cut off at the bottom. Just write neutrons right here. You didn't do all this. See the numbers up there? Like, all you have to do is follow along and write the stuff down. You've got to stay on track. Anything, remember, anything in red needs to be written down. I've made it super simple. Okay, you're gonna have to write the word neutron here. There was just a blank left off. See, it's in the red over there. So, again, I say the word isotope, you say neutron. Neutrons are what changes. Okay, let's do some examples. What is the isotope here? You need your periodic table. What is it and what isotope is it?
11.
Yes, but what is the name? What element has 7 protons?
Nitrogen.
What is it?
Nitrogen.
So this is nitrogen what?
Nitrogen. 7.
No, what do we say? We use the nitrogen what?
7.
Not nitrogen 7, no.
Nitrogen 8.
No?
Neutrons.
So remember though, okay, we need to go back. Let me go back. We're going to label something else. It is nitrogen 15, but I'm going to go back for a second. Okay, I want everybody to circle this 6 right here. Lithium 6. And label it mass. That's the mass. Lithium 6. So when I pull this next one up, this happens to be nitrogen 15. Remember, you have to use the mass. Nitrogen 15. Okay? nitrogen 15. If we're going to do the symbol for that, it would look like that. Mass, what is this? The number of protons. Okay. Questions about those? We're going to practice in a minute. Let's take a look at ions. Other side, what is an ion? Ion is an atom with a different number of electrons. So if I say isotope, you say neutron. If I say ion, you say electron. So an ion is an atom with a different number of electrons than normal. This means the overall charge of the atom is no longer neutral. If it gains some electrons, it's going to become negative. If it loses electrons, it's going to be positive. And there are two types of ions. There are cations and anions. Cations are positive ions, that means they have lost electrons. And anions are negative ions, that means they have gained electrons. Remember, those electrons in that outer shell, they want to have a partner. Sometimes they will lose those electrons, and sometimes they will gain them. They'll pull them in so that they have a partner. But they will always have a partner. One way or another. They will always have a partner. Okay, let's take a look at how this looks.
Wait, on the lab we did yesterday, that one that was over there only had one electron on the outside.
So it's going to have, it wants to have a partner. It was hydrogen.
You said it will always have a partner.
It will. That will either lose that, it's going to lose that electron.
The one that loses, that's the only one that has.
It was hydrogen, and it is the only one it has. And the way hydrogen loses that electron is by bonding with something, and then they share electrons. So they're sharing them with hydrogen. It's not actually lost, they share. Okay. Some atoms are going to actually lose them, and we're going to talk about which ones on the periodic table actually lose them. And some of them do something called share them. Now, if hydrogen doesn't have an electron, it doesn't have to have it. It's just hydrogen. It's one proton, and that's it. It's hydrogen. So if it loses that electron, that's okay. It's still hydrogen. Okay? So on this one, how many protons does it have?
3.
How many electrons?
And
3. So with 3 and 3, is that neutral?
No.
Yes, it is, because they cancel each other out. So there is 0 charge there. 3 and 3, that means there is 0 charge. When there is 0 charge, that means that it's neutral. Now, let's say that this little electron on the outside wants a partner and it finds somewhere to go. What is it going to do? It's going to leave. So now we have only 2. So now we have 3 protons, which are plus, and only 2 electrons, which are minus. 3 minus 2 is what? 1. So now we have something that has a 1 charge. So this atom is no longer neutral. Now it is an ion. So an ion is an atom with a charge. Okay, that's all it is. It's one that has lost or gained electrons. This now has its own symbol, and it's lithium 1+. And it's a little 1+ up in the upper right side. Right here. Look at the screen, please. Lithium 1+. Okay, lithium 1+. Now, how do you determine whether the atom is going to lose or gain electrons? Well, this is how it is. If it has 5 or less electrons, it's going to lose them. If it has 5 or more, it could gain them. Okay? And that's how you determine it. It's on your periodic table. Anything on the left side of the periodic table, groups 1 and 2, have 1 valence electron and 2 valence electrons. What are those going to do? They're all going to lose electrons. The stuff on the other side of the periodic table is usually going to gain them. Okay? Now, when it's a 1+, when it's a positive, it's called an cation. A cation. Okay, let's take a look at another one. Here we have oxygen. Oxygen has 8 protons and 8 electrons. Okay, that means it's neutral. How many valence electrons does oxygen have? Outer shell. 6. So it's more than 5. So is it going to lose them? No, it's going to gain them. It has 2 empty spots here. So it's going to gain 2 electrons. They won't though. They won't. Because, and this is the why. How many electrons does it want to have in that shell? 8. So if they went together, would there still be 8? No. It wants to have 8 in that shell. And that's the reason it's going to gain some. Okay? So when it gains some electrons, it's protons, and look, it's gained 2, the little model, because now it has 2 extra. The protons don't change, but the electrons do. What's 8 minus 10? Negative 2. So now the charge is negative. And it's oxygen 2 minus. And it is an anion. Okay, we're going to be practicing this, so don't stress about it if you're not catching on. We will practice so that you get better at it, okay? We will practice it so that you get better at it. Now I'm just going to walk through again so you can see what happens. Here, this one only has 1 valence electron. This is lithium. Everybody find lithium on your periodic table, please. Put your finger on lithium, please. Open up your periodic table and find lithium. Okay, how many valence electrons does lithium have? 1. Here it is. Something in that column, everything, from hydrogen all the way down to, what's the last one there, radium or francium? Francium. They all have 1. So what is every one of those things going to do with that electron? It's going to leave. They're going to lose it. So all of those are going to become an ion. With how much charge? 1 plus. That is called being chemically reactive. When an element is chemically reactive, that means it's changing its electrons. Okay? Reactivity has to do with that valence number. How many they have. Okay? This one is oxygen. Everybody find it? Look on the periodic table. Go up. How many valence electrons? It has 6. It has 6. It's not going to lose 6 of them. It's too difficult to lose 6. It's much easier to find 2, which it did. Okay? So it also becomes an ion. Okay? It's much easier to lose 1 than to gain 7. You understand how that works? So 5, actually 4 is the cutoff. Carbon could go either way. Carbon could either lose 4 or gain 4. Okay? Anything lower than that is usually going to lose them. Okay, let's do some practice together. You can go ahead and glue that down. Page 17. We're going to do some of these together, and then you're going to get to do one yourself. Yes, you may. Well, those don't follow the rules. They don't follow the valence rules. We're only talking about the ones that have valence. Okay? And you'll need that foldable out on your desk to help you do this. So don't put your foldable away. Just to go with this table. Okay, we're going to do one example on the board. This is beryllium. Beryllium. What has happened here? How many protons does it have? How many electrons should it have? Does it have 4? How many did it lose? It's lost 2. So now it has how much plus charge? 4. And how many negatives? So 4 minus 2 is 2. So this is an ion. Does it have a plus or minus charge? It has a plus because it has more pluses. And this is beryllium 2 plus. That makes it is it a cation or an anion? It's a cation. The way you can remember that is the T, think of the T as a plus sign. Make it a lowercase. Cation is plus. Okay, cat is plus. Okay. On the sheet I handed out, let's take a look at it again. That 16 is not what goes there, it's from last year. Okay, let's take a look at this. And I'll pull it up on the screen and we will work some of these together and then I'll let you do one yourself. Okay, the first thing we're going to do on this side is isotopes. These are isotopes, and there is an example given to you, so just pay attention. This is lithium-6. Here is the symbol for it. And this is lithium-7, and here's the symbol for it. What does lithium-7 have that lithium-6 doesn't? No. Remember, for isotope, let's write it down. It's neutron. Okay, remember isotope, neutron. Notice here, how many does it have? 3 neutrons. And here, how many does it have? 4. Okay, so let's do this next one. Carbon. Somebody tell me, how many protons does carbon have?
4.
Carbon. 6. Okay, this is carbon 12. So how many neutrons would it have?
6.
It would have 6. Remember, these two have to add up to that. Make yourself a little note like that. Okay, so this is carbon 12. Carbon 12. And this should have been a 6 here. I apologize. This is a typo on my part. Let's change it. That should be a 6, not a 7. I apologize. Okay, did everybody have this sheet? Make sure you're following along. Okay, this one is carbon 14. How many protons does carbon have?
7.
No, ma'am? 6. All carbon has 6. How many neutrons does it have?
7.
No.
8.
It would be 8. Remember, this has to add up to this. That's how you do this. Now, we also have to do the electrons. 2 in the first shell. We need to get to 6 of them. So 1, 2, 3, 4. Are the electrons going to change over here? No, because this is not an ion. So the electrons are exactly the same. So the only thing that changes in an isotope is what?
Neutron.
The neutrons. Everybody do the next one, oxygen. Everybody do the next one, please. Draw those two models. And then I'm going to go over them with you. I'm going to be walking around and make sure you're doing it properly. Again, what is the only thing that changes? The neutrons. Okay, so the 8 goes there. No, because you need the number of neutrons. What do you do to the mass and the protons to get the neutrons? You subtract, because whatever's in here has to equal 16. Make yourself a note of that. That has to add together to get that. Okay? Grab your sheet, please. How many protons do you have? It already does it right here. I've done that for you, so you're supposed to be doing this. What's that? 10 more. Yeah, that's because that adds up to what? 18. That's right. Keep going. Draw your electrons a little smaller. 6 plus 8 is what? Why did you put 6 here? This is oxygen. See how many protons is oxygen? Right there for you. 8. Okay, now remember, these two added together give you the mass. So it has to be there to get that. These two added. Okay. This is 6. Take 6 plus. 8 plus what will give you 16? You have to add them. Okay. What's 8 plus 8? What should it be? It should be 18, so what changes this? That means it's not be 8, so it needs to be 10. Show you. If you're not sure what to do here, ask. Freddie, you gotta go sit over here. Right here. Okay. These two added together will give you 16. Okay, this is still oxygen, so it still has 8 protons, so that goes there. But now you have to add these two together and get not 16 this time, but 18, so what needs to go there? 8 plus what is it? Do you think you have it? Raise your hand. Okay, you need to do this. How many protons are in oxygen? No. It's 8. Okay. Where's your notes? We just label all this in your notes. Where's the sheet we just did? Okay, hold it up. You didn't do This here is the mass. This here is protons. Okay, so when you're drawing the bottle, how many protons does this have? Okay, these two added together give you this. So 8 plus 1 is 16. That goes there. 8. Okay, let me do this one for you. You check your answer. I'm going to call on somebody to tell me what to do. So Farrah, you're going to help me with the first one. Farrah, oxygen, how many protons does it have? 8. It does. Oxygen will always have 8, so we can go ahead and write 8 over here. You get that from the periodic table. Or you can get it from right down here. I want everybody to circle that and label it proton. That is the protons. This 6 right here is the protons. That number on the bottom there is always the protons. You don't even have to go to the periodic table to know the protons, unless this is the only thing given to you. If on the test it's oxygen 16 given to you, then what are you going to have to do? Go to the periodic table and see how many protons oxygen has. Now we know oxygen has 8 protons. This is oxygen 16. This number at the top is the mass. That is the mass. Remember, only the nucleus has mass, so 8 plus 8, Farrah, what 8 plus what is 16?
8 plus 8.
Yes, that would be the correct answer there. Now, we need 8 electrons, so there's 2, 3, 4, 5, 6, 7, 8. And there would be our Bohr model for oxygen 16. Everybody needs to be looking at the board and paying attention. Okay? Now, on this one, Jace, we have oxygen 18. We have 8 protons. Jace, how many neutrons are we going to have?
10.
We will have 10. 8 plus 10 gives us our 18. This is oxygen 18. We still need 1, 2, 3, 4, 5, 6, 7, 8 electrons, and there would be our answer. So here we have 8 protons and 8 neutrons. Here we would have 8 protons and 10 neutrons. And there would be the answers to that. Okay. We will practice this in isotopes later. Let's turn over and do ions real quick. Okay, on the ions, remember the ion, the atom is going to lose electrons or gain electrons. For sulfur, 30
2. Sulfur 32. How many protons does it have? It has 16. To get to 32, how many neutrons is it going to have? It's going to be 16. 16 plus 16 is 32. Now, we want to make sure that this says it's a neutral atom, so our charge has to be 0. We have 16 pluses, so how many electrons are we going to have? 16. They have to cross out, so we have 2. Okay? Do we have enough shells here? No. Well, we will draw another one. There's 10. We need another shell. 11, 12, 13, 14, 15, 16. There we go. Okay, so that is our sulfur, neutral. Now here it says, what has happened? What is sulfur going to do? Is it going to gain or lose? Well, no, it has 6.
Okay.
It's going to gain 2, so that's the reason it's gone to negative 2. So we still have 16 protons, but now, because we've gained 2, we don't have 16 anymore, we have 18. And that makes the charge 2 minus, which is what is on the symbol there. Okay. So now when we draw it, we still have 16 and 16. We have 2, 8, and now this shell is going to also have how many? 8. And now both shells are full and it's happy. Remember, the atom wants to have its shells full. All of the electrons have a partner. Okay. Neutral, sodium, it has 11, so it's going to have 11. Okay, and that charge will be 0, because there is nothing here. Here, there's a charge, so this is going to change it here. So we have 11, it's 22, so 11. 2, 8, and we need another shell for 1. What is that 1 electron going to do? It's going to leave. So our electrons are going to go from 11 to 10. We're still going to have 11 pluses. So now it's going to be more pluses, so it's going to be 1 plus charge. And we will have 2 and 8, and we do not have to draw that third shell. That electron left. Okay, changes in which subatomic particle determine isotopes. Not for isotope. Isotope, I told you, remember, neutron. What changes in which subatomic particle determine ion? Electron. This is participation. If you've done it, put your name above your ID, put it in the box, and you'll get 100. If you didn't do it, you should have been following along and doing it. You may need your journal out to do your exit ticket today. Yes. Also, you need your green folder for homework. The green workbook. So everybody grab your green folder, please. We'll do pages 3 through 5 in the science workbook, green folder. It's not a folder either, I've mistyped there. You have a green folder?
Yeah, but I forgot to bring it.
If you don't have a workbook, come get one. What?
need to put that in our folder. You have a green folder? You have to put it in something. You have a green folder? Green folder? Why not? Blaine?
You have to do third grade?
Were you always in that spirit? You never got a folder? Well, you were supposed to bring a green folder. Bring one? Green folder stuff. You need a folder. See if I have any folders. See if I have any folder. I do not. You have to read page 3. Read page 3 and do page 4 and 5. 3, 4, and 5. That's your homework. And we missed out on the exit ticket. I forgot my iPad, my timer was on my iPad.
See you tomorrow, Mr. Paul.
You have a great day.
You too.